Attention is equivalent to mental capacity. We can devote resources to basically only one demanding task at a time. If we're doing two tasks, then we can devote our attention to the two tasks simultaneously, as long as they don't exceed the total capacity available. The route to automaticity is practice and memory. With enough of that, then we have the overlearning, which comes from repetition. It brings the ability to perform automatically what formerly needed conscious processing or attention. Something that can be done automatically does not require attention. It might be helpful to think of attention as a spotlight, illuminating whatever it is you're paying attention to. However, it would be more accurate to think of paying attention as actively turning down the volume on whatever you're not paying attention to. Our minds are bombarded with information. The mind must actively inhibit whatever it is that you need to turn down. So you can think of anything you don't want to pay attention to as noise. You need to turn it down below the attentional threshold so that the information you do want to pay attention to can be heard, and then the noise doesn't intrude on the conscious stream of thought. Inhibition is used to silence things that we will not pay attention to. I'm sure you're familiar with the test, do not think of a pink elephant. The first thing you think of is a pink elephant every time. People with OCD have even more trouble with that than the rest of us. Attending to one of two incoming messages and shadowing or repeating it aloud demands conscious and deliberate attention. Such a process is under direct control. A person is aware of performing the process, and it consumes most of the available resources that can be allocated. If you just give it a try yourself, you can see that you can't really do anything else at the same time. No other conscious process can be performed simultaneously with the shadowing task without affecting the performance of the other task, or possibly even both tasks. In dichotic listening exercises, participants hear different stimuli in each ear. This exercise is used in experiments, such as the one that's one of the optional assignments this week. You can choose between, I guess it's not really optional, because you can choose between dichotic listening or Stroop. And I'll talk a little bit about both of those in this presentation. Noticeable differences in this task include changes in pitch, substantial speed differences, or sex changes, and the cocktail party effect. So that is to say, if you're hearing two different things in each ear, and then one of them speeds up substantially, you will notice that. Or if, let's say, in your left ear it's a man speaking and then that switches to a woman speaking, you're going to notice that. And again, the cocktail party effect, where if every now and then one of the speakers in one of your ears says your name, you're going to notice that as well. Some things that you won't notice, which might be a little surprising, are changes in language, changes in the content of what the speakers are talking about, changes in speakers, and changes in speed without a change in pitch. We can use ear dominance as a diagnostic tool.
As artist Judith Neosi describes it, the color in her life faded when she slipped into a major depression.
I didn't want to do my hair, didn't want to shower, I didn't want to do anything. It's not that I didn't want to, I couldn't. I didn't have the energy.
Doctors tried many drugs before finding one that helped. Psychiatrist Jonathan Stewart says Neosi's story is typical.
Matching the patient to the treatment is totally trial and error right now.
Neuroscientist Gerard Bruder, working with Stewart, may be on the verge of changing that. Writing in the journal Neuropsychopharmacology, Bruder reported developing a listening test that taps into left brain, right brain listening and language functions. In a study of 215 patients, the test seems to predict who will or won't respond to antidepressants. Wearing headphones, patients hear two different words simultaneously, one in the left ear and one in the right. Then they mark the word they heard. Their choices indicate which side of the brain dominates. Bruder says left brain dominance in listening corresponds with success in antidepressants, particularly in women.
We found that women who had above normal left brain advantage for hearing words had about a 95% chance of doing well.
Bruder hopes the test will give psychiatrists a treatment edge and help get patients on the drugs that'll work for them more quickly. I'm Oren Schoenfeld.
Aside from dichotic listening, you might also be familiar with the cocktail party effect, where you suddenly hear your name even though you weren't paying attention. Just hearing your name triggers your attention, and it seems to do so even retroactively. There's more information about that in your textbook if you're interested. Let's move on now, though, to talk more about working memory and working memory capacity. Although you can practice working memory skills, you pretty much have whatever working memory capacity you were born with. So don't believe those online programs and apps that say you can improve it, because they just want your money. You might do something often enough that you think that you're improving your working memory because suddenly you can do two skills at the same time, but it's much more likely that one of those skills has just become automatic. And remember from the presentation so far that anything that's automatic doesn't require attention anymore. So now we'll talk a little bit about the Stroop task and Stroop effects, as well as top-down and bottom-up processing. Mental activation of a concept can come externally or via the spread of that activation from one's concept to another. Hopefully that'll make a little bit more sense after the next slide.
Historically, sensation and perception have been treated as separate processes, but they are interlinked. Originally, it was sensation, then perception, in that order. The idea was that your senses would collect information, and then your mind would make meaning out of it. According to this view, sensation is primary process of data reduction and analysis, and perception is the process of extracting meaning from the sensations we receive. The value of the model was that it emphasized the difference between internal and external states. We collect external information through our senses and then process it internally. Collecting is external, and processing is internal. As it turns out, we're not that simple. We use both bottom-up and top-down processing at the same time. Bottom-up processing is inductive. You take this bit of vision and that bit of sound. Then you combine all the bits together into a full understanding of your situation. In contrast, a top-down process means that what you are thinking impacts what you see. The pattern of previous information sets up expectations of what is to come. And given that expectation, you put more emphasis on finding what you expect to see. The Stroop effect is a good example of top-down processing. Here are 4 colors we will use: green, blue, yellow, and red. When you see a new stimulus, say the color you see, not the shape or label of the object. Don't say triangle or square, say blue or yellow. Don't say cat or horse, say red or yellow. Don't say the word red if it's written in green, say the color. Ready? Here we go. Green, blue, yellow, red, blue, blue, green, blue, yellow. As you can see, we are pre-programmed to process verbal information differently from visual information. People begin having trouble saying the color when they see the object as a word. We want to process words as words, not as visual objects. I stumble over this process every time, and I know what's coming. So knowing about it doesn't make it go away. It's an automatic process. We don't just collect stimuli and then figure out what it means. We add meaning to the collection process. So it's not sensation and then perception. It's teamwork. We use top-down processing to anticipate what's coming next, and bottom-up processing to fill in the gaps.
The Stroop test is not only a neat way to demonstrate competing attentional processes. It can be used to diagnose a number of disorders, including eating disorders, anxiety disorders, and depression. Why does the Stroop effect occur? Well, there's parallel distributed processing of the tasks your mind does automatically. You read and recognize colors pretty much automatically. So when you see the Stroop stimuli, these two automatic pathways compete with each other to give you the correct answer. They reach your central executive, and basically they bottleneck with each other. If you look here and I ask you to find the T, it's not very difficult, is it? In this case, you're going to use parallel processing. You'll just kind of look at the picture and you'll take in all of the information at the same time, and it's pretty easy to find the T. In contrast, if we do a combined feature serial, you'll have to use serial processing. See how much easier it is to confuse a T with an F than it is to confuse a T with an X? This can be explained by feature analysis models, as is explained in the text. This is one of the questions on this week's quiz, by the way. R and P are easily confused with each other, but not with W, because many of their basic features are the same. By the way, when I mentioned the quiz, did I get maybe a little more of your attention? There's also another phenomenon we find with the visual search, and this has to do with whether you're searching for feature present or feature absent. If I ask you to find a circle with a line in it, and I show you this picture, it's an immediate process. You can work with bottom-up processes where you're just using the sensory information. You don't need anything cognitive, and it pretty much sticks out like a sore thumb. On the other hand, you might need to use focused attention and bottom-up and top-down processing if I ask you to find the circle that does not have a line in it. So we'll find that people take longer for picture B than they do with picture A. This is also true of motion, as Raine et al. Discovered in 2001. Keep in mind that when your brain processes visual information, it isn't only the visual cortex that's involved. All of your brain is at work almost all of the time. Top-down processing has to do with higher order cognitive thoughts interfering with sensory-driven perception. Look at this girl. Now, you would probably say that as you're looking at her, your eyes are pretty still and not moving very much. But if we track the exact focal point of your eye, we see that it actually bounces around. In this image on the right, we see how the eye has fixated and saccaded between fixations. So each of the lines, you can see they looked a lot at each of her eyes, and then at her nose and her mouth, and then a little bit around in her hair. But you're not actually looking at just one specific spot when you look at something, and that's what saccades are. We also see saccades while reading.
Lördag är jag ledig från skolan som vanligt. Då ska jag åka och bada med min kompis Lisa. Lisas pappa ska äntligen lära oss att filma. Det ska bli spännande, tycker vi båda två. Min man is Niklas Andersson.
In this video, you can see the young girl focuses on every single word as she reads these sentences in English. That's because English is her second language. But she was much quicker when she read it in her native language, and she actually didn't focus on every single word.
Lördag är jag ledig från skolan som vanligt. Då ska jag
She skips over very many of the words.
Läsa, skriva, skriva, lära sig.
You might notice next time that you read something that you're not actually even looking at every single word. Now let's talk real briefly about consciousness before we wrap it up. Consciousness can be defined as the awareness people have about the outside world and about their perceptions, images, thoughts, memories, and feelings. I'm sure it's clear how this is tied in to your attention. It's generally associated with controlled, focused attention that is not automatic. We don't have very much consciousness, however, about our higher mental processes. We have little direct access to our thought processes. Even though you can think of an item once it's conjured up, you don't actually know how you got to the conclusion. And you'll probably say something like, "It just came to me." So there's a difference between products and processes. You have access to the products of your consciousness, but not to the processes of your consciousness. Verbal reports by people in experiments can be somewhat accurate. However, we really do have limited access to awareness about the step-by-step procedures in a motor activity. We have only limited access to some thought processes, such as whether our attention is drifting, how well we understand something we've read, which is why it's so important to continue quizzing and testing yourself when you're trying to study for something. And our awareness of step-by-step procedures in a motor activity that's become automatic. These are things that are known as metacognition, when you know about your own process of thinking.